All right. Let's go. You guys and gals, much love. Yeah. Man, I have to say it. Guys, gals. Right to my heart. Man, I appreciate the views that you've been given on the last few episodes, streams. It's great to see. It is truly great to see those out there learning, liking, enjoying my content. Man. Now, on the other hand, I'm not sure if you're enjoying it, but just jokes, guys. Just jokes. Man, it's so great. It's so great seeing them views. Remember, a big part of this, guys and gals, it's you that keeps this going. Yes. I'm enjoying the teaching part of it. I know I'm kind of starting with the stream a little bit later than usual. Busy day. Busy day. That's what I'll say to you. And I had a nap too. Not sad. So busy I ended up having a nap. Hopefully I'm awake now. Let's go. Doing it for you, guys and gals. Those of you that have been watching, you guys are great. I can't say it enough. I cannot say it enough. I also want to quickly shout out recent follows, because every single one of you are awesome. Well, every one of you guys are awesome. Those of you that are watching the content and learning, super awesome. Beautiful, intelligent people. 120 plus IQ club. Every single one of you. Yes. I love it. You guys are great. Okay, just scrolling through my document. My eye molecules are still trying to wake up here. Slowly. Okay, let me check a different document here. Yeah, I think it's this one. Okay, try to. Yeah, I got the right one. Let's see. We're almost there. Close. There we go. Shouty outies to all you supporters, recent subscribers of the channel. Gonna shout you out. I mean, there's a lot of you guys. I would love to shout out every single one of you. Jamu, I appreciate you dropping by last stream as well. Jamu, hope you are doing well, brother. Okay, let's go. Followers, Nikki Trey 66, Bart number 1, Jim Jam 1238, Kazert KH at Assert 20, and Gavin 555, Kamikaze ML, and most recent follower, I Ducky. Where's that? Pipe, Mario Pipe Ducky. I don't know. I'm not sure if that's an I in front, but that's okay. I'm gonna call you I Ducky, because you're probably like saying, I am Ducky. I Ducky. I love it. Thank you for the follow. Turn it up. It's warm today, guys and gals. I want to have the fan on, but I don't want to give you guys the background sound of a fan going. I certainly could use it. Woo! Hot and muggy. How do you guys do it? How do you do it? In case you don't know, a lot of you are probably used to this Celsius. I grew up with Imperial. I don't know. We do things weird over here, different, I guess. Celsius, we are at 29. That's 84.2 degrees Fahrenheit. A lot of you love that temperature. A lot of y'all love that temperatures. Most of you are used to it, which is fine. I'm not saying that's bad. But for us up here in the north, we're used to the cold. Cold is like our, comfort zone. Crazy, I know. Crazy thoughts. Crazy thoughts. Actually, we love summer and stuff over here too, guys. Okay? Don't get us wrong. Don't get it all wrong. There's a lot of us up here that love the summer and the spring. Everybody's kind of different. People like the heat. People like the cold. That's just how we are. That is how we are. Ours is. Whoops. Took advantage of some coffee. I went to go put my cup down. My cup is like 20 fluid ounces. And yeah. Well, you know what a mason jar is. Basically, it's a mason jar. Except it's called an Atlas Mason. And I drinks my coffees out of that. And there's no handle either. So it's cool. Alright, in my terms, it's cool. But anyways, this is for you guys and gals. We're going to get to it. I kind of like to chat with you a little bit, before we kind of jump in. If you want to get right to the content, if it's not live, right, by all means, you could, generously skip forward. That's okay. That's good. It's great to see that. You just want to get right to learning. I love it. Okay, this is for you guys and gals, every single one of you watching the content, you viewers, those peoples that love to learn. I love it. Supporters of the channel, followers, lurkers, and twerkers, this is for you. That's right. That's for every single one of you beautiful, intelligent people. I love it. Thank you for the support here on the channel. Much love. Okay, where are we now? I guess we could get right to things. It is time. Let's see, here we go. Today we are beginning with working with variables and constants. Variables and constants. I'm always learning over here, guys. Of course, I have a different document open because, I'm just always practicing. Always trying different things, Always learning, always growing. The great thing about C++, it gets so intensive deep that you get to spend more learning time on it. It's awesome. It is awesome. All right, the key thing is to get a good solid foundation, guys and gals. We all have to kind of start there, right? Get the basic fundamentals understood. All the little different data types, the syntax, bit of the theory, an understanding of what's happening under the hood. It's kind of a common saying. All the magic that happens when you run a program and those sort of things. And then looking at the script and understanding, if you could look at it and go, I know what that is, right? You know what I mean? You look at it and you go, I know what that is, right? So yeah, it's great. Once you get all that down, you can actually read and try to understand other people's code. Everybody kind of writes, they have their own unique way of writing code. For the most part, it's all, the layout and such is very similar. Writing your statements and such, very consistent. There's always a certain way that you have to type things. Things belong in certain positions in your statements, and you just have to be consistent. You follow these, that's all your syntax, right? You follow those rules, you know, wherever you have an understanding where everything goes, what you're using, when you're using it. It's gonna get a lot easier. Okay? Trust. Alright, it's really, C++ is really not that bad, guys. Again, it's the main foundation language for building full-blown applications, right? It's the main one, okay? I'm telling you. It's not a subset language. It's the main language, okay? It's not the poser language. It's the real language. I'm telling you. It's great. Okay, so, all right, let's get to this. I have the right program now, our brand new one that we started, we've been working on. I'm going to keep all that. I think I'm going to keep all this. I don't want to get this too long. I'm going to try not to. Let's see. I could kind of get rid of this. We don't really need this anymore. You understand that, you can have these extra curly brackets. Create an extra block of code. We'll clean things up here. Local variables and such. We'll just clean things up. Okay, GitHub link I already gave. I'm gonna get rid of that. Some to-dos, just reminders. Namespace we're not using. Gonna get rid of that. If you want to have, here's a thing too, guys, right? A little bit of a tip. Okay, go to your Solution Explorer. You should have it pinned, and then the name of your solution, right? This is a solution essentially. Click that right here, right click properties, and then right here it'll show you your C++ language standard that you're using, okay? And you can change it, okay? You might even be on 14. Now each standard kind of has, I don't know what the best word to use for that. The line, the syntax might be different in a different language. It just depends on which one you're using. Okay, so be aware of that. I just dropped it on 20 because, it's basically the most current. And yeah. All right, so that's how you do that. Because you will get different kind of errors and such depending on the which one you're using. All right, that is your, we'll just go back there, which your language standard essentially. Okay, and there's other things you could do in here, but for the most part, Visual Studio, the fine developers, they set it up pretty good for you. All right, so just make sure you're on, when you're working, creating a brand new program, just make sure you're on debug. You can change this stuff. You can change whichever, I don't know, does FAT32 still exist? Is that still a thing? I don't know. I haven't booted up a FAT32 system in a long time, so do they even exist? I know it's not supported anymore. Yeah, I don't think it is. There might be some old school dude out there running Fat 32 still. 32-bit essentially is what I'm talking about, or x86. Just realize that 64 is obviously 64. It refers to the your operating system architecture. Okay, guys. All right. Some extra notes here for you guys and gals, just because why not? You know, learning, right? We're learning here, and I love it. I'm glad you're learning. Okay, let's learn. Let's do some learning. Did I say learning enough? I don't know. Turn it up. Okay, working with variables and constants. Let me actually check the stream here, make sure we're good. I should make sure that we're okay. That's good. Okay, good. All right, I'm not being a bad mod. So far, so good. That we're okay. All right, perfect. Yes. Awesome, awesome. Awesome, awesome. All right, just wanted to quench my thirst, and now I'm gonna let's start. We're gonna be working through the course outline now. Okay, working with variables and constants. Programs need a way to store the data they use or create. Okay, so it can be used later in the program's execution, right? It's data, right? Information it needs. It's necessary and required to make the magic happen, all right, guys? Variables and constants. We all know what a constant is, right? If you weren't sleeping in mathematics class, you know that pi is a constant, right? When we're talking about circles, 3.14, that's a constant. Variables, such as x and y and z, zz. Other variables you can have are, name variables such as tomato, potato. It doesn't really matter because it all cooks the same, boys and girls. It all cooks the same. Variables and constants offer various ways to represent, store, and manipulate that data. Data can be changed, right? The information stored can be changed, so be aware of that. This stream, you'll learn how to declare and define variables and constants, how to assign values to variables and manipulate those values. I've been kind of doing some of that stuff already with you guys and gals if you've been following along, right? We've been in, initialize, declare, initialize, declare, initialize, right? You know what I mean? How to write the value of a variable to the screen, right? Or to your console. Excuse me. What is a variable? In C++, a variable is a place to store information. Okay, take note there, guys, right? So that's the key thing right there. Any information, whether it's a string literal or an integer value or a decimal value or whatever, that information gets stored into the variable. It's the variable that holds it in memory and puts it in place, okay? A variable is a location in your computer's memory in which you can store a value and from which you can later retrieve that value, okay? Notice that variables are used for temporary storage. Okay, what is your temporary storage? If you're a computer guy, you'll know what your temporary storage is. Notice that variables are used for temporary storage. When you exit a program and turn the computer off, the information in variables is lost. It's gone, right? It's been deallocated, essentially. So this is part of the coding language that you'll get used to these words: allocate and deallocate. Okay. Permanent storage is a different matter. Okay. Like permanent storage, what they mean is like your hard drives, your C drive, your SSD, or your NVMe, or your 3.5-inch, hard drive, right? The mechanical style. Hopefully you understand computers a little bit. You know what I'm talking about. That's your permanent storage, right? That information is never lost. Okay, so typically the values from variables are permanently stored either to a database or to a file on disk, right? Database, there you go. Database, I haven't really worked with databases very much. Of course, I've worked for large companies and they would have servers and what else not, but I imagine that's kind of where that database would be, is kind of like in a server room or such, right? Storing to a file on disk is discussed later in advanced inheritance. Okay. Storing data in memory. Okay, your computer's memory can be viewed as a series of cubby holes. Well, I'll give you a little diagram, a visual here so you can see. Normally the word that's used is containers, right? Think of a box as a container, right? Your computer's memory can be viewed as a series of containers. Each container is one of many such holes all lined up. So imagine you have like 10 boxes, okay? 10 empty cardboard boxes. And you put them all beside each other in a line, like in a linear fashion. Okay, so each container is one of many such holes all lined up. So they're all lined up. So imagine that. Each container or memory location. So each box essentially is like a singular memory location, is numbered sequentially. Okay, these numbers are known as memory addresses. Okay. Now, don't let it scare you guys, right? You don't need to fully understand hexadecimal. Just think of it as numbers and letters put together to create a memory address. Don't look at it too deep, okay? Whatever's happening under the hood, we don't really care. We just have to have a general understanding, okay? So the point is, don't let these hexadecimal values, turn you away or scare you off. Just organize in your mind. Just think of it as like a mixture of numbers and letters. Okay. A variable reserves one or more containers in which you can store a value. So each box you can store a value, right? I'm just going to use the cardboard box concept as an analogy. Your variable's name, for example, might be my variable, or it could be called my husband or my wife or whatever. I mean, variable names, they're your own creation. You're the one that has to create the variables. Us as line coders are the ones that have to create the variables. Okay, and there are standards to writing variable names, but we'll get to that in the future. Okay. So your variable's name is a label on one of those containers so that you can find it easily without knowing its actual memory address. We don't need to know it. Internally, the computer, knows the memory address. Just think of it as like somebody delivering food, right? Every house has an address, right? They can't deliver the food if there's no house addresses, right? So look at it like that. Okay, so I got an image for you. So is a schematic representation of this idea. All right, so I'm just going to use like a quick snippet, but I'm not going to actually save it. But there you go. All right. Okay, so schematic representation. As you can see from the figure, my variable starts at memory address 103, okay? Now that's not hexadecimal, but you know, it's human, easy to understand. We all recognize the number 103, right? Okay, depending on the size of my variable, it can take up one or more memory addresses. Okay, so again, here's the word RAM. Okay, what is RAM? RAM stands for random access memory. That's your temporary memory. So if you don't understand computers much, right, you have your permanent memory, which is your hard drives, and then you have your temporary memory, which is your RAM. Okay, they're usually sticks. Okay, just to give you a general example. Okay, when you shut your computer down, those sticks of RAM or sticks of memory basically get cleared up. And so when you turn your computer on again, it's brand new, fresh, essentially ready to use again. Right? All the memory, the spaces of that information is being stored has to be cleared up and, you know, ready to use. Okay, so, oh yeah, there we go. RAM stands for random access memory. When you run your program, it is loaded into RAM from the disk file. All variables are also created in RAM. When programmers talk about memory, it is usually RAM to which they are referring. In the beginning, I wasn't sure about that, but now I fully know that that's where it is, right? Your CPU or your processor, pretty much, it's kind of, the temporary memory is kind of like a temporary, like obviously I could say the words temporary storage, but you can think of it as kind of like a library for your CPU, right? Imagine a whole bunch of library shelves, okay? Look at your memory like that. And your CPU is the librarian, and it'll organize the books sequentially however it wants to based on, you know, codes or numbers, i.e. memory addresses. Right? You can look at it like that. Think of your memory or your RAM like it's a library. It's another good way of looking at it. Okay? So that's a sample, right? Stuff could be stored here, 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 right? Now notice that everything's kind of in order. This is the word sequential. You'll hear the word sequential. That's what this means. Kind of like in series. Sequentially. Nothing could be in between, right? All this space is allocated for my variable. Okay? You understand? All of this is my variable. All right. Setting aside memory. When you define a variable in C++, you must tell the compiler what kind of variable it is. Right? This is part of the declaration, right? Okay. I'm just going to go like this, for example. Okay. Here I've declared. This is our variable. I could type x variable. Right? There you go. Okay. We have to equal it to something, right? So remember, whatever's on the right-hand side equals to on the left-hand side, right-hand side equals left-hand side. So whatever's here is stored in here. So this is like the variable, right? Get used to that concept. Right-hand side equals left-hand side. So whatever's here is stored into here. Okay. If I actually run this, let me see here. I don't do debugging much, or I don't use the debugger much, but I can. Do I use this one here? This is without, so I'm gonna run it. Okay, watch, here we go. It's really going to do that. Locals, go back to here. I just want to hover over. Right now it's kind of x is equal to 0 here. Analyze the copilot. No, don't care. I'm going to skip. I'm going to go skip forward. Now jump down here. There we go. See, I skip forward. Now you can see that the value 22 is stored into X variable. Okay, that's all I wanted to really show you. It's one way, using this is a great way to kind of see what's happening under the hood a little bit. All right. Okay. Let's carry on. I just wanted to kind of show you that quickly. Let's see, an integer, integer, a floating point number, a character, and so forth, okay? You must tell the compiler what kind of variable it is, all right? This information tells the compiler how much room to set aside and what kind of value you want to store in your variable. It also allows the compiler to warn you or produce an error message if you accidentally attempt to store a value of the wrong type in your variable, okay? So this characteristic of programming language is called strong typing. We don't really need to know that. If you're doing an exam, maybe you might need to know that, but it's not a common lingo that's usually mentioned. So yeah, declare. All right, you hear that's coding lingo right there. You want to remember. Declare, initialize. Declare, initialize. Okay? And obviously your variable. Okay? Here's another thing. I might as well tell you this right now. What's it warning me? These little 3 dots, it's saying right here, it's already telling me local variable is not initialized. Okay, guys? Variables need to be initialized. So if I go like this, it might not even let me run it. Let me just see. We'll find out. We'll see if it lets me run this. Okay? So I'm here right now. I'm not into the variable yet. Right now it's saying 0. I don't know why it would say 0. It should say something else, but I'm going to skip forward, and it's still saying 0. Okay, so the new... Oh, is that what you guys are doing? All right, cool. So before... Going back to prior... I'm not sure which one, but prior... maybe 14 or something. I don't know exactly which one. I don't memorize these sort of little details. But prior to that, now the fine devs have done something to make things better. Prior to that, your variable would store garbage. And remember when if you've been watching the stream and I used the wrong, I meant to use the variable I created, but I ended up using the function name to kind of return to the console, and it gave me like a hexadecimal kind of value. That wasn't a memory address, that was garbage. So basically it looks like hexadecimal, but it's not. So going on to this, now obviously, like, we still have to initialize it. It's telling us to initialize it, right? Basically what that means is give it some sort of value, right? But I ran this, it looked like it still was 0, which is kind of neat. So technically speaking, so going here, skipping forward, right here's where I am. We're at the print fault. Whoops. Well, it doesn't really matter where I put it. We're kind of after this anyways, but it's still saying 0. So that's kind of the point I wanted to mention, guys. Prior to whichever version language that you're using, before it used to be garbage. Now, obviously I'm using 20, So they've probably set it up however they did the code in the background. The variable is actually 0. But either way, I'm going to carry forward because I think I do apologize if I kind of go on and on about something or a topic. It's because I want you guys to, I want to try to, I'm trying to explain it, but I want you to fully understand, right? So bear with me if I kind of go on and on. I'm just really trying to help you understand, okay? So basically initialize, all right? So let me show you a little trick. I'm going to show you now. You'll see me doing this. Here's another way. You can actually use brother and sister curly bracket to initialize to a value of 0. This is the way I like doing it. You notice how the error went away? So you can either type, now it's up to you, whichever you like. You can type equals 0 if that's what you want to do. Or you could type just 2 curly brackets. It doesn't mean body. Basically, we're initializing the variable to 0 just using 2 curly brackets. It's cool. I like it. So right now, here it still says 0. I could skip forward, skip over, step over. We're stepping to the next line. You can see where it jumped right here because of the arrow. And at this point, you know, it's still saying the variable 0. So, just another way of doing it. Okay, guys? I figured I'd show you my little trick. If you see me doing this, that's what that is. That's me initializing my variable to 0 without typing equals 0. So, technically speaking, I'm using less characters. Am I? Or am I not? I don't think I am. All right. I tried to justify it in my head. For me, I like it. I just like the way it looks. All right, so it's a preference thing. Okay, each container, I'm going to call it container because that's kind of the lingo, is one byte in size. Okay. Now I'm going to show you a little diagram. I don't know if it's going to be this stream or sometime, and it's going to happen. But I'll show you how many bits and bytes a data type needs. Okay. It's actually set for us. All right. That's key. You need to know how much space is allocated in memory based on your data type. Okay, hopefully that makes sense what I said. You'll see it. I'll show you. All right, stay tuned. Stick around. All right, if the type of variable you create is 4 bytes in size, I might even mention it now, just reading the course outline. We'll see. Okay. So for I guess this is a hypothetical, I think. Let's read it again. Each container is 1 byte in size. If the type of variable you create is 4 bytes in size, it needs 4 bytes of memory, or 4 containers. Okay? Let's just bring that up again. Okay? So it's a little bit more, but right, each one is a byte. 1, 2, 3, 4. So that's just for one data type. Okay? Okay, there was a time when it was imperative that programmers understood bits and bytes. Okay, after all, these are the fundamental units of storage. Guys, just to be clear, memory is very important. Memory is very important when it comes to coding and C++, okay? Don't slack on the concepts of memory. It may seem like it's trivial, but it's very, very important to understand memory because it's basically everything. And it boils down to the speed at which your program that you're creating is operating, right? You know, a lot of it, the speeds in milliseconds are really quick. It's hardly noticeable. But with that said, right, it's critical. Okay? Memory is critical. It's very important. All right. Computer programs have gotten better at abstracting away these details, but it is still helpful to understand how data is stored. Okay. For a quick review of underlying concepts in binary math, you could look at working with numbers, binary and hexadecimal. Okay. Binary, I could do binary math as part of my IT program. I loved it. I'll even maybe in the future do a little program converting, binary. Okay, from that to basically like an IP address. Okay, stay tuned. I can do it. But hexadecimal, that's another thing. That hexadecimal is a lot deeper. IPv4 is easier than IPv6. I'm just saying that. Hexadecimal is doable, but it's a little bit deeper to understand. All right, so if mathematics makes you want to run from the room screaming, don't bother. I love math. I don't know why people are scared of math, man. Once it clicks, if algebra, for me, when I was grinding algebra problems, once it clicked, man, I was in there. I dove right in. I took over the whole swimming pool. I don't know what. It's algebra is the foundation to calculus. That's all I'm gonna say. If you can do algebra, it could, because it's the foundation, right? Anyways, I love math. I truly do. Okay, the truth is that programmers no longer need to be mathematicians, right? You don't have to be, right? Not every coder. There's coders out there, I'm sure, that are great at reading and writing, and then there's coders out there that are great at math, right? Because everybody's kind of different. We're not all created equal. We have our strength. Everybody has strengths and weaknesses. I don't care who you are. Okay. That's important. Okay. Though it is important to be comfortable with logic and rational thinking, right? And if you're on the right, then you're definitely logical and a rational thinker. Sorry to say. I need some coffee. Is my compiler still open? It is too. All right. Let's continue. Size of integers. Okay. On any one computer, each variable type takes up a single, unchanging amount of room. That is, an integer might be 2 bytes on one machine and 4 on another. Okay, now, with that said, that's based on the architecture. Okay, so now computers are now 64-bit architecture, right, guys? So basically an int is 4 bytes now. But FAT32 or 32-bit architecture, it was 2 bytes. So with that statement that I read, that's basically it in a nutshell. Okay, 32, obviously people must be still using x32 or x86. So anyways, that's okay. Just take note, if it's an integer is 2 bytes, it's most likely an x86. If it's 4 bytes, it's an x64. But on either computer, it is always the same day in and day out. Okay, single characters, including letters, which I call char, numbers, and symbols are stored in a variable of type char. A char variable is most often 1 byte long. Okay? The endless debate about how to pronounce char. I mean, when you spell cherry, you don't go carry. Right? We pronounce the ch, right? If you're, language arts 101 stuff, we say ch. Some say it as car, some say it as char, others say it as care. Okay. Again, I always say this: potatoes, tomatoes, tomatoes, who cares? It all cooks the same. Clearly, car is correct because that is how I say it. But I'm reading what they're saying in the course outline. I say char. Okay, but feel free to say it however you like. Okay, semantics, guys and gals. It's all semantics. For smaller integer numbers, a variable can be created using the short type. Okay, yeah, it's something you can do. I don't usually use it often. In the beginning when I was coding, I'm like, I want to save memory. I'm going to use short, right? Kind of adamant a little bit. I want to do the right thing. Okay, I was like that. Man, it's heat. Mugginess. Okay, a short integer is 2 bytes on most computers. A long integer is usually 4 bytes. And an integer without the keyword short or long is usually 2 or 4 bytes. Again, it depends on the architecture. You'd think the language would specify the exact size that each of its types should be. However, C++ doesn't. All it says is that a short must be less than or equal to the size of an int, which in turn must be less than or equal to the size of a long. Okay, I'll show you that image shortly here. It might happen. That said, you're probably working on a computer with a 2 byte short and a 4 byte int with a 4 byte long. Okay, let me show you the diagram since I said all that, just so you can, for ease of understanding. The size of an integer is determined by the processor, 16-bit, 32-bit, or 64-bit. Again, that's the architecture, okay? I'm using a 64-bit operating system. Okay, there is a way to check your operating system. Just type system information in your down here, system information in your search, and yeah. Okay, and then it'll tell you. Just look for something that says, if it says x86, you're using 32-bit. If it says x64, you're using 64-bit. Okay? 16-bit, I don't think, I don't know. Does somebody have a 16-bit OS still? Or a computer? I don't know. On a 32-bit computer with an Intel Pentium processor using modern compilers, integers are 4 bytes. Do they even sell Intel Pentiums anymore? Wild sauce. I don't know. I used to design computers and that, but people weren't buying them. They'd rather buy the off-the-shelf garbage instead of a custom build. So, for about 5 years, I was trying to get a PC business going. But I don't want to go on a tangent, but man, people are cheap. They'd rather buy the garbage, the throwaway garbage, because, I don't know, maybe they don't understand. I don't know. My shit is custom. You ever see that Resident Evil movie when the black dude's he's got gold eagles, and he's like, my shit is custom. Sorry for swearing, guys. It's probably the best part of the movie when he said that. It definitely was custom. All right. Let me bring up that diagram. Where is that? In here? Yes, I found it. Okay, and I need... Where are you? Right here. Okay, there it is. Okay, here it is. Okay, so I believe this is 64. This is what I use as a standard, so it has to be. So a char is one, it takes up, allocate. So this is the allocation part, okay? So basically one container, okay? And then here on the right, this refers to the ASCII table. Now I'll show you quickly, okay? You don't need to know this now, but I'm just gonna show you just quickly. Each character is on your keyboard is associated with a number. Okay, we can actually access this information. We'll do more in the future. Stay tuned. It's going to be great. Okay, so I just wanted to show you that quickly. That's what this means. Okay, I'll open it again. Minus. So for char, minus 127. That's the number that they're showing here. Okay. Okay, these are all those weird characters. I don't know. That's Russian, I guess. I don't know. I would always, whenever I was playing Call of Duty back in my PC days, COD 4, Modern Warfare 1, PC grind, I would see this kind of in chat or text chat, game text chat. I'd be like, okay, that guy's Russian. I used to slap the Russians. Yeah, I love it. Okay. There you go. That's what the number is. Okay. Minus 127 to 127. That gives you an idea what these values mean. Okay. And that's in regards to the char and an unsigned char. Okay. That's ASCII table only right here. 0 to 255. 0 to 255. Okay, 0 is null, 255, all right? Okay, so an int allocates 4 bytes, okay? This is your actual, like now we're talking about real numbers, okay? Now, they're using a dot, but these are actually supposed to be commas, okay? Comma, comma, comma. I can't fix that. I mean, I guess I could edit it, but... So basically, this is 2.1 billion. Okay? So, that's your range. Notice your range is negative. Now, hopefully you haven't been sleeping in mathematics class and you understand the integer grid. Do I have that? I know I have a mathematics thing. Do I need to really do that, guys? I don't know who you are, right? So I don't know if you understand integers. I hope you do. This is key. You need to understand integers. Let's see. Math. It's gonna take me a minute to find. I do mathematics teaching videos as well. I'm kind of organized in my file system, but I'm kind of not. I don't know. Is it what? Maybe it's documents. Oh goodness. Mathematics. I did a scan and such, and I have them scanned to a PDF. Let's see if I can find it. Maybe I have it. I don't know. Times table, integer grid. Here we go. I found it. Yay! Okay, I'll share this with you. What? Come here. What the? Get over here. Okay. I have to rotate it. Well, get lost, you cheapskates. Everybody's always greedy, always want money. Rotate view clockwise. There we go. Okay. This is the best way I can fit it on a piece of paper. Okay. Integer number line. Okay. 0 is center. Okay. All positive numbers go to the right. Okay. So you can cut this piece of paper in half and just connect the zeros. Okay, so this is all on the right side here. Okay. From 0, positive numbers go to the right. Infinitely. Okay, that means forever. Okay. Okay, mathematics, numbers are infinite. Okay. All right. I don't want to go on a tangent, but those that like brag because they know how to spell, they know when to use the your and your in a sentence. Yawn. Not all of us are stupid. Okay. Alphabets are only 26 letters. Okay. All right. I'm gonna move on. Okay. Integers move to the left, negatively, and also infinitely. All right. Okay, so that's your max, and this is your min. Okay, so that's your actual real number range. So if you're using whole numbers, right, integers, whole numbers, you could actually store a value up to 2.147 blah, 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 2.147 billion. All right. An unsigned int basically means positive. Okay, so from 0, positive direction only. You can notice basically it's like taking this and adding it to this. Gives you that. I don't know how accurate it is, but it's going to be close. Again, some of the bits and bytes are, especially for an int, it has to have a bytes allocated for the sign. Okay, that's why they talk about unsigned, right? This would be a signed, right? But we don't have to be explicit and call it assigned. All right, so unsigned, positive only, basically. From 0, you could go up to 4.3 billion, basically. All right. You get the idea? So if you type short int, you have to know the range, right? So that's why you're being specific in regards to which data type you want to use. So if you only want to use numbers, let's say your numbers are going to be less than 32,000. Okay, this is 32,000. Again, zeros here, positive 32,000, negative 32,000. Okay, that's your range. I know you guys can understand this, right? I want you guys to fully understand it right from the get-go. Okay? Again, just be aware. If you type unsigned short int, that's your range. That's how many bytes. Okay? If you want, just do a snipping tool, new, and you can snip that if you want yourself, by all means. Or you can search, I don't know, something on the internet. You might find something. Okay? Blah, blah, blah. Let's see. Where is that again? Here. Okay, was I finished? Not quite, but you get the idea, right? And then you got floats. I know these are all weird numbers and stuff, but basically, if you haven't slept in mathematics class, it's basically 38 times 10 to the 7th power, right? Which is like a massively large number. It's huge. Like it's definitely over 2 billion. Okay, so you have quite a large range for float, and you have quite a large range for double. Now notice that floats are 4 bytes. It allocates 4 bytes of memory, and double allocates 8 bytes. Okay, and you can get a lot more with a double. Okay, that's the difference there between a float and a double. So if you're confused, again, float and double, decimal values. Okay, so if you're like, well, which one do I use? I don't know. Oh, the humanity, right? You know, you can make your decision based on how much memory you want to allocate and your range, right? Let's say your numbers are going to be less than 3.4 times 10 to the 7th power or whatever, however that works. It's just, trust, it's huge, okay? All right, let's continue. How are we doing for time? Buongiorno! Let's go. Much love. Thank you for the comment. Appreciate you. How are we doing for time? Let me see. Oh, actually, wow. We got lots of time. Okay. Awesome. All right. I'm going to delete that. And then we're going to create, so, I don't know, I guess they'd be local variables to int main, okay? These are local variables to the int main, all right? Just make sure we're okay. We'll run it. There we go. Boom. And then I'll go like this. Hello. One of my friends on Twitch likes to drop by, say hello once in a while. He's been pretty committed to being part of my stream. Hello, buongiorno. If you're on Twitch, by all means, check out Buongiorno. Nice guy. He really is a nice guy. I love him. Okay? Not like, you know, I love him as a person, as an individual. It's been great. Okay, and then I'm going to just fix all this. I just was kind of showing you, you know, that in order to get space, you have to actually add the space. Because again, space is a character in a string literal. All right? All right. Boom. It's supposed to be a smile, but how do you put a smiley face? There we go. Let me see. I want to try something out here, actually. Which one is that? I guess we'll try this, see if it works. But it's kind of silly, but no, it doesn't like it. Some characters are not allowed in code. Not allowed. Not allowed! Not allowed! There's another channel you guys should check out. He's on Twitch and YouTube. If you want to watch somebody, I'm going to shout him out. He probably doesn't know I'm doing this, but I'm going to shout him out anyways, because he's a hardworking guy. Like, the commitment and dedication to his work, and he's creating his own game It's kind of like if you like Pokemon and card games. Now I'm not saying his game's Pokemon, okay? But if you like card style games, if you like RPG type games, if you like deck builder type games, if you love deck building type games, check out deck builder type games. Check out I know I should know his name, but I can't think of it off the top of my head. I'll find. There it is. He's got a unique name, which is kind of cool. Check out RIY Ryan Art. Okay, he is a C++ developer. He's doing his game in C++ language. I don't know what GUI or interface he's using, but he also does 8-bit 2D artwork. He's pretty awesome. Okay, check it out. Check it out. Control X, Control V. It's gonna go like this. It's gonna go like this, like this, like this, like this, and like that. There we go. Okay. Control Shift B and run it. Okay. And he's got his game. His game's on Steam. Game is called Woods of War. Okay. That's the name of his game. You guys have no idea what it takes to make a game. I'm not being rude or mean, but yeah, it's a lot of work. I tried to do my own 8-bit pixel artwork. Whoever can do pixel artwork, you guys are amazing. It's like amazing. I pretty much went straight to doing 3D because it was easier for me than the 2D. I was doing a little bit of some 2D pixel art. I did some ghost animation, some movement while you actually control it. Anyways, I didn't mean to go on a tangent, but yeah, if you like deck builders, check out Ryan Art. His game on Steam. It's called Woods of War. Okay? He's getting close to it being done. It's amazing. If I could, I do want to buy it, but I need to grow and bring in an income myself. So the struggle is a little bit real over here, guys. So, but that's okay. What I do is I just keep pushing, keep grinding, and trying to stay positive. All right, let's go. Let me just see. Let me do this. Want to fix this up like this. Make sure, again, if you've been following, update. If you change the name of your function, make sure you update it. Okay. And I don't know, sideways smile. That's all I could do. Okay. And then I was just gonna stick this in there too. Control X and Control V. There we go. And then there we go. And let's just see what it looks like, okay? There we go. Okay. I need some space there, I really do. I really want it on the bottom is what I want it, but that's okay. Alright, there we go. Some space, it's cleared up a little bit. Anytime I run it, then that's going to be run every time. Okay. Alright, so let's write some code using standard CL. I'm not going to be lazy. I guess, I don't know. Now it's up to you guys, okay? So you can do this if you don't feel like typing STD all the time, okay? You can do that. Double colons, okay? Or you can type using, I think it's namespace STD. That does the same thing. Okay? But I'm not like super adamant about it. Some companies might be adamant about it. I recommend you just get the habit of doing it, because maybe just maybe you might end up working for a company that's adamant about you typing the I know I called this a class, but I think it's a namespace. Come to think of it, it's either a class or a namespace, one or the other. Okay. I'd have to confirm that. Is standard. I should know this stuff, but I don't really focus too hard on stuff like that. Is STD a standard? No. Is it a class or namespace? C++. Okay. Okay. Standard namespace. It is not a class. Okay, there we go. That confirms it. Okay. I knew it. I started thinking about it a little bit more because I called it a class. And I don't know, I was doing something and I wasn't watching any video or anything. It just came to my head. I'm like, the bells and whistles came up to my head and I'm like, what am I doing? Right? I don't want to steer the people that I'm giving instruction to. I don't want to steer them wrong. I don't want to give them the wrong information. So I'm kind of glad I remembered this. So standard refers to the standard namespace. As a matter of fact, typing that should have been the bells and whistles in the head, in the old brain molecules. Whoops, namespace. That should have been the bells and whistles right there. Ding, 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 ding. Oh, silly me. Lil, did you not find a boyfriend yet? She is afraid. I don't know how she expects to have kids, little kittens, if she's terrified of going outside. All the boyfriends are outside, Lil. Are you scared of the coyotes? Take her outside. She's just terrified. There's not much I can do about it. She's been an inside cat all the time. There we go. Okay, and there's the bells and whistles right now. It's really being explicit and saying Standards and namespace. Hello, Bob. So now that we're clear about that. Okay. Don't be lazy. I'm just typing. That's why I don't really pay attention to it, because I don't use it, right? I choose to fully write it out now. All right, so what do they got? The size. Here we go. Let's do some learning. Let's start typing stuff, okay? Of an int is, and then actually we're going to use the, hopefully you've been following along and you know what that is. What are they typing there? Okay, size of, here's how you do it. Size of, okay? Now I think it must be part of the unsigned long search online. Size of, I would imagine it's part of the IO stream, maybe namespace. IO stream include or class. Size of int. Okay, this is how you do it. Okay, you use this is actually a function here, guys, and it's called size of. Actually, I guess it would be a method, because it's most likely inside of a class. Now, I could probably peek the definition in that, but I'm not too concerned, okay? All you really need to know is, let's not get too deep into it, guys. Just look at it. Anytime you see words and two parentheses or brackets, automatically tell your brain, ding, 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 ding. Oh, that's got to be a function. Or if it's inside a class, that's got to be a method, right? So inside your brackets, now we're putting in our argument, okay? The parameters are already set up in the background code, okay? And so you notice how we're, again, this is the format. When you're writing code, right, the code has a certain format. And so now you're learning, guys, how to do that. So here we have a string literal, open quotations, close quotations. Then we have a brand new set of O-stream operators, okay? And then we put in our, like this, we could actually have a variable. If we had a variable here, we could just write our variable name, right? That this is kind of like, I don't want to use the word calling it, but we want to access the information. So this method is going to get the bytes, the size in bytes of an int. It's going to display it for us. It's going to be amazing. Check it out. All right. And then finish with a period, and then there. Okay, and then we could do more. So I'm just going to copy and paste. Now remember, when you do that, don't forget to update your information, right? You could have issues. I don't know how I would do this. Maybe I could use brackets just to separate it, to make it clearer for you guys to see. Okay, so now we're gonna do for a short int, right? And this little diagram that we brought up here, this is what we should get when we return it to the console. Okay, short int, we should get 2. All right, let's find out. And then so make sure, right? If I don't change this, the compiler is not gonna give me wrong information, right? You as the code writer have to type your code or your statements properly so that you return the correct information to the console, right? If I don't change this, then I'm just returning an int again. So here we just type short. We don't have to type short int. Let's check out some other ones. What about a long? Okay. Size of a short int, size of a long int. And again, this is how you can check. Let's say you didn't remember. Let's say you didn't have this list. Okay, let's say you didn't have this list. Maybe you didn't have this, not list, but diagram. Let's say you didn't have this. Maybe you don't feel like, maybe you feel lazy and you don't want to search the internet. So you could actually just type this, return this to the console. All you need to do is you need this. All you need is this and a semicolon, and there you go. Okay, so let's continue. What else? What about a char? Should we do a char? Okay, so I'm going to change my information. Updates. That's the key thing. Don't forget to update your information. All right, you're just going to get the wrong output if you don't, okay? So my main point is, like, it's recommended that you don't copy and paste, right? A lot of people, maybe in the industry and such, they're adamant that they might be adamant about you not copying and pasting, okay? Because the reason is it's easy to make human mistakes, maybe overlook something, maybe an oversight, and then maybe you end up having to spend 8 hours trying to debug 1,000 lines of code when it's something that's just simple as you forgot to change this to an int. You know what I mean? Right? These things can happen. Right? So they recommend that you just type it all out. That way you don't mess things up. Unless you set it in your mind to, I don't know how you want to do it, but, right? Don't just copy and paste and then expect, the result to be, the correct result. Okay, floats. We'll do them all, I guess. We haven't talked about bool at all. Float double, let's do double, right? That's the other data type we've been talking about. And lastly, bool. So bool is just think true false, okay? We'll talk about it more, but bool is a true false. That's why I hate typing bool, true or false. We'll talk about it briefly or quickly. Okay, bool is a true or false statement or return. Okay, in conjunction to true and false, respectively. True is 1 and false is 0. So if you think we've talked kind of a little bit about binary language, right? Binary language is what? Computers or processors work on zeros and ones, right, guys? So you could kind of think of it like that as well. I think of it also like back when I was doing electrical theory. I think of it like a light switch, on and off, on, off, on, off, right? On is 1, off is 0. Okay, so there you go. That's kind of a breakdown of what a bool is. You can use them in your script. Okay, so here we go. Make sure I didn't mess anything up. So int, short, short. Okay, size of, they're all size of. It's the same method that we're using. Long int. Long char. Okay. Float. Right? It's pretty straightforward. Double is double. And bool is bool. Okay. Let's build this. Run it. And check it out. There we go, guys. I should have actually a space. But isn't that nice and clean? Look at that return. That's the tab. The \T is the escape character. T for tab. / escape character. T for tab. And it puts it nice in line. It's beautiful. That \T is a beautiful thing. Size of a short int, 2 bytes. Size of a long int, 4 bytes. Char is 1 byte. Actually, should be singular. Float, 4 bytes. Double, 8 bytes. Bool is 1 byte. Okay, so we'll have a look. So bool and char we have to fix. Right? Bool. And char. Okay. And let's quickly look at that. Hopefully it's the same. Char, yeah, see, char, 1 byte. Bool's not on here, but now you know. Okay, short int. Short int, 2 bytes. Long int, 4 bytes. And that's how you can quickly access the information. Let's say you didn't know, right? And you didn't feel like researching it. That's the line code you would use to access that information. We didn't need to go, this overkill. We could have went like this. Just to kind of keep it simple. You don't really need to go that much. Really all you need to do is go this, to be honest. That's all you need. I guess we could go like that. Whoops. This should actually, I like doing singles for single. Okay. Just as an example, right? So again, this is in bytes. Okay. Just to be clear, bytes. And we'll build it. Run. There we go. See, short is 2 bytes, long is. Now I got this messed up. Oh, because I got rid of most of the information, that's why, right? So my point there was, this is all you need to return. You don't need to return all this. If it's just for your own case use, for reminding yourself, all you need to do is just write that. That's it. Right? And it's 1. What's the size of a char? 1. Okay? Isn't that fun? That was fun. Alright, I want to go like this. Actually, I gotta go like this. Like this, like this. Make sure this says char. We go. All right, there we go. Oh, and I got rid of the bytes part too, so I'll fix that as well. Boom. Oh, plural, singular, singular, plural. All right. So there you have it. Okay. Now remember, it depends on the architecture too, right? You can actually get more allocation with the x64. Okay. It's going to be half with the x86. Okay. So just be aware of that. All right. That's your memory allocation. So if you declare an int, it's allocating, because I've declared it, my variable to be an int. It's going to allocate I don't have an enter, but it's 4 bytes. Okay. 4 bytes. What happened here? What? Let me just see. Okay, there, it's fixed. All right, good. Okay, so signed and unsigned, right? So you'll hear those terms, right? Just remember, an unsigned basically is all positive. Okay, that's all you need to remember. A signed, you have negative values. That's the difference. Unsigned, all positive from 0, starting from 0. Okay, let's say you're not going to have negative numbers in your code. Let's say you're writing making a program or whatever. You're going to save on memory too, right? Bits and bytes, guys, bits and bytes. Runtime bits and bytes and file size bits and bytes. It all adds up. All integer types come in 2 varieties, signed and unsigned. Sometimes you need negative numbers and sometimes you don't. Any integer without the word unsigned is assumed to be signed, right? You don't have to be explicit. So there's a word there that, remember this word, explicit. Okay? That's another coding lingo. Being explicit. Right? That's kind of like this here. We're being explicit. Well, that's a bad example. In the future, I'll show you'll see code written in such a way where, I don't know, I'm just going to think of how I could do this. Sometimes you'll see that and maybe it's, I don't know, something beside it. Like maybe it could be a variable or something. I don't know. But you'll see it kind of in front. That's being explicit to what type of return you want. You'll see that kind of in the future. We're not going to worry about it too much. But again, that's being explicit. Okay? It's basically like being clear about something, right? Okay, so when we don't have to type signed, but if you want it to be unsigned, you're being explicit. That's what I mean, okay? Any integer without the word unsigned is assumed to be signed. Signed integers can be negative or positive. Unsigned integers are always positive. Integers, whether signed or unsigned, are stored in the same amount of space, okay? Because of this, part of the storage room for a signed integer must be used to hold information on whether the number is negative or positive. Okay, so take note, if it's signed, it's going to have negative numbers, right? That negative actually has to be stored as well. So a byte of memory is actually allocated for the sign. Okay? We don't type positive for positive numbers because it's inferred. We all know that if there's no sign, it's a positive value, right? Mathematics 101 stuff, guys. Okay. The result is that the largest number you can store is in an unsigned integer is twice as big as the largest positive number you can store in a signed integer. I don't know if that made any sense, but that's okay. For example, if a short integer is stored in 2 bytes, then an unsigned short integer can handle numbers from 0 to 65,535. Okay, alternatively, for a signed short, half the numbers can be stored are negative. Thus, a signed short can only represent positive numbers up to 32,767. Okay. Now if I bring that up, you can see that here, right? Okay. For more information on precedence of operators, we'll go to operator precedence. All right, well, we're going to carry on. How much time are we at? We're getting close, okay? Fundamental variable types. Several variable types are built into C++. They can be conveniently divided into integer variables, the type discussed so far, floating point variables, right, i.e. floats, doubles, and character variables, okay, such as chars, right? Floating point variables have values that can be expressed as fractions. Okay, be aware, guys. Take note. You can type your code to, like for example, let's say we're typing something. We're doing an arithmetic calculation. Okay, I haven't showed you this yet, but 7 divided by 3, right? So the forward slash, a singular forward slash, is actually our division symbol, okay, encoding. Just like the star is our multiplication. Okay, when you look at code and script, you'll know what's what. You're going to see this used in a different way sometime in the future. Okay, this symbol actually has more than one function or purpose in line coding. Okay, just to give you a heads up. Okay, so my point here is, let's say you're doing a calculation and it's 7 divided by 3. The console's not going to return a fraction. Okay, so take note of that. It actually does the division, 7 divided by 3, and it returns it to the console in a decimal format. Okay, so be aware of that. That's why your data types are critical. If you want a float or a double return to the console, you have to be explicit, float and double. If you use int, it's just going to return an integer or a whole number value, okay? Pay attention to that, right? We'll talk about that again, but that's, yeah, just as a heads up for you, all right? That is, they are real numbers, okay? Floating point variables have values that can be expressed as fractions. That is, they are real numbers. Characters variables hold a single byte and are generally used for holding the 256 characters and symbols of the ASCII and extended ASCII character sets. The ASCII character set is the set of characters standardized for use on computers, right? That's how the magic happens on our keyboard when we press things on our keyboard, guys. The ASCII is what's doing all the magic, right? Every time you press a key on your keyboard, you're actually pressing an ASCII code, if that makes sense. Okay, there's a correlation. Okay, so ASCII is an acronym for American Standard Code for Information Interchange. Nearly every computer operating system supports ASCII, although many support other international character sets as well. So we'll bring that back up so you can see it. Okay? We don't really care about all these other ones too much. But the ones obviously on our keyboard, ASCII number 32 is for space. There it is right there. Remember how I said space is actually a character? Right? When we're typing code? Right here, that's a space, right? These are all spaces. These are all ASCII characters, essentially. Now, I don't think I can fully explain it under the hood how that works. How they, do that with the ASCII table and that. The main important thing, guys and gals, is to have an understanding of this, okay? All right, we can actually return these values too to our console. We can use them in our code as well, okay? So we only really care about 32 to 127. That's all we care about. The rest of them are kind of just, right, these are all important, but these are all like the extended, right, which we don't really care about too much. So, all right. The types of variables used in C++ programs are described in the table I'm going to show you here. The table shows the variable type, how much room the type generally takes in memory, and what kinds of values can be stored in these variables. The values that can be stored are determined by the size of the variable types. So check your output from the listing to see if your variable types are the same size, okay? It is most likely that they are the same size unless you are using a computer with a 64-bit processor. Okay, let me do this. Snipping tool again. And here we go, okay? So this is kind of similar to what I've already showed you. Okay, again, if you want this, you can snipping tool this. I don't know why I would do that again, but that's okay. All right, so you can snipping tool it if you like. Again, this is if you weren't scared of, mathematics, you would understand scientific or engineering notation. Essentially, that's kind of what this is here. Okay, mine was incorrect, but this is correct right here. Okay, the one I showed you guys, the information is kind of incorrect. It's not correct down here for float and double. But then on the other hand, 32-bit, 64-bit, that could be the difference, right? Okay, you can see here, right? 16-bit, 2 bytes. 32-bit, 4 bytes. Right? So be aware of that. Depends on the architecture. The size of variables might be different from those shown in the table that I just showed you, depending on the compiler and the computer you are using. If your computer had the same output as was presented in the listing or a table, should apply to your compiler. If your output from the listing was different, you should consult your compiler's manual, blah, blah, blah. Okay? Again, I'm using Visual Studio, the built-in compiler I'm using. Other people use Visual Code or whatever. I'm using Studio. There are other ways to write code, different IDEs. Just depends on what you want to do. Some have a terminal, which you would type what I would call kind of like similar to typing Linux code. But just depends on how you want to learn and what kind of level you want to be at, I guess. Defining a variable. Okay, so we're going over the basics, the fundamentals, all the important things that need to be learned with, to become I don't know what the best way to say it, but to be awesome, right? To be able to do this, right? Got to get that foundation down, the terminology, the theory, all those things. It's very important, guys. All right? Try to, want to do this. Stay positive. I believe in you guys, okay? Every single one of you. All right? It's all part of learning and bettering yourself. Again, 120 IQ club, right? Remember that. Keep yourself motivated. Even if you have to, I don't know, soak toothpicks in orange juice and then use those said toothpicks to hold your eyelids open. Okay? It's just jokes, guys. Just jokes. I think I've seen that on Fred Flintstone. I don't know. Anyways, up to this point, you have seen a number of variables created and used. I guess we kind of have. We haven't really created a lot of variables. We'll get into that. We'll do more. Now it is time to learn how to create your own. Okay, here we go. You create or define a variable by stating its type, right? So that's kind of what we're doing here, right? Let me just cut that out. I don't want to get crazy with these comments, but I'm going to go like this. Explicit, yes. Being explicit. You have to be explicit in your statements as well. All right, so most of the time you guys are going to see int. I don't know, a lot of people, I mean, it depends on the person, I guess. Maybe it depends on the business or company. Maybe they want you to use shorts. Maybe they want you to just use longs. Maybe they want you to just use unsigned ints. For the most part, you're going to see a lot of statements with just int used or double used. That's common. It's the ints that are different. The int has more than one way of doing things, right? You have short int, right? Int is the one that's kind of unique, expanded on, right? If you will. All right, so we're just going to use int. We're going to, we're not really creating any programs that are, we're not releasing anything here. This is just for learning and educational purposes only. So we're not too concerned, okay? But we are going to do our best to write proper code and make sure that we're doing things, the best to our abilities, okay? So here we are, we're declaring, right? Coding lingo, declare, initialize. You'll see those terms if you have any errors in your error list or your output. You'll see the words declared or not initialized. You'll immediately know what that means, okay? Again, this is our variable. Right-hand side equals left-hand side. That means this is stored in here. This is stored in here, okay? This is just declaring what type. Be aware, guys and gals, you only have to declare a variable once. So if you were to use the word declare again, or declare int, you don't type int again, okay? You don't. You only need to declare once in code, and that's it. All right? So that's a little tip for you. You can create or define a variable by stating its type, followed by one or more spaces, followed by the variable name, and a semicolon, okay? All our statements always end in the semicolon, okay? All of these statements, every one of these is a statement, okay? The variable name can be virtually any combination of letters, but it cannot contain spaces. So you're not allowed spaces in your variable name, okay? Not allowed! All right. I'm stealing that from my good friend on Rian Art. He says that, and I like it. He does a little voiceovers and stuff. It's pretty cool. I love it. Not allowed. You gotta check out his channel. He's on Twitch and YouTube. You'll find it. Okay, support the guy. He's working hard, man. He's working hard. And he's an indie developer, all right? It is not an easy gig. I'm telling you guys, if you think it's easy, you really need to pull your head out of your donkey. Okay, I'm being nice here. All right. The variable name could be virtually any kind of blah, blah, blah. No spaces. Legal variable names include X. Here's another example. I'm just going to kind of copy it. I'm just going to go int. We'll declare it equals, I don't know, some other kind of number. Right? So as you can see, the 23 in front doesn't look... Oh, that's what it is, because I didn't copy everything. Okay? Take note. You can have numbers, but it has to precede by a letter first. Okay? If you notice, you can't start your variables with numbers. Okay? Little things here. And then here's a common one you'll see, right? Very common. You'll see a lot of variables that look like this. Okay? Very common. Good variable names tell you what the variables are for. Using good names makes it easier to understand the flow of your program. The following statement defines an integer variable called myAge, right? So again, if you don't initialize, the program is going to yell at you. Already down here it's going, it's not initialized, not allowed. Okay, so initialize it. It's a starting value. 0 is a starting value. Take note, when you creating a program, the value can be changed and then restored into the name. Okay, so this value can change. You can change the value that is stored in the variable myAge. Okay, that's all during runtime stuff. Okay, when you declare a variable, memory is allocated, i.e. or set aside. That's what allocated means for that variable. Okay, right? We've talked about it. How much space is allocated for an int? It's 4 bytes, right? On a 64-bit architecture. Okay? So, little things to remember. All variables have a memory address. Okay? So it's a location on our temporary memory, i.e. our RAM. So at that memory address, we stored the value 0, right? It's kind of like, it's no different than, let's say it's int house 1 equals 5. The house has an address, right? And there's 5 people living in that address. That's probably the easiest, most simplest way I can explain how that works. So take note, a variable, we're going to use house for an example. That house has a memory address or an address location. And then inside that house has 5 people. We're just going to pretend the number 5 is 5 persons. Okay, does that help? I'm going to drop the yays for that because that deserves some yays. I took advantage of some coffee there, which is now empty. Okay, continuing on, and we'll finish up here. We are just about done. We are actually done. But I'll finish up here. As a general programming practice, avoid such horrific names as this, okay? Okay, avoid that, okay? All right? Not allowed! Because it doesn't make sense, right? We're trying to create variables that are human readable and make sense, okay? It has some logic, right? This doesn't mean anything to anybody. So let's say somebody's going to review your code. They're going to look at this and go, man, this guy just didn't care, right? That's the way they're going to look at you. They're going to critique, man. I'm telling you. They will critique. Okay. And restrict single letter variable names such as X or I. I mean, you'll see them used. You'll see I and J used a lot. That is okay. When we get into doing for loops. But, I mean, I've used int X. I mean, depend if I'm doing something that's like, I don't know, let's say I'm working with triangles. But I guess I could, elevate my variable name to X triangle or X horizontal or something. I don't know. Depends on what I'm doing, right? I don't know. There's different rules. We'll try to figure out some rules, okay? All right, some guidelines to make creating variables easier for you. Again, what they say actually is a real thing. Coming up with variable names is probably the hardest thing about coding. And it kind of is. It kind of is. Right? So, all right, let's continue to variables that are used only briefly. Right, X and I, right? For loops, you'll see X and I, okay? They're only used. So they're saying single letter variables such as X or I or Y and J. Restricted to variables that are used only very briefly. That's what they're saying. Try to use expressive names such as my age or how many. Such names are easier to understand 3 weeks later, right? We're human, right? So, like, I back up a lot of my script on Notepad. And you might come back to your program that you're creating and then you'll be like, what was I doing? Right? That's a real thing, guys. Such names are easier to understand weeks later when you're scratching your head trying to figure out what you meant when you wrote that line of code, right? So make it kind of human understandable, right? What does the function do? Or what is the purpose of this variable? Okay? Try to experiment. Guess what these programs do? Okay, so here I'm gonna get rid of all this. Okay. Again, if you're watching and following along, you could pause. You could type out the line code that I'm doing. You can definitely do this yourself as well. Okay, so let's do this. You're going to see a lot of this. In this course outline, they use a lot of the unsigns in that. So I could copy and paste this. We're not doing it inline here. We could actually do this inline, but I'll show it like this. I'll show you. So this is one way of doing it. Okay, so they have. Now we're going to type a little formula. Z equals X times Y. Okay. So what they're saying here is try this experiment. Guess what these programs do based on a few lines of code. what's this going to do? Okay, let's look at it. We've declared an unsigned short. We've created our variable name. The other problem is I can see a little dot there. Right now it's saying not initialized. Okay, so that's a problem. The program wants you to initialize. Now it's up to you. You could go equals 0. I guess I'll just go equals 0. Okay, there we go. We've initialized it to some value, at least something, right? It's a starting value. Let's say up front you don't know what they're going to be, right? Now we have this line here, z equals x times y. So right now everything's 0, so if we actually input the values, basic math 101, right? Z is going to equal to 0 times 0, right? So essentially our return, if we actually output to the screen, Z's going to be 0 as well. But technically speaking, it already is 0 because we initialized it to that value. Now we haven't returned it, right? That's the only other thing that's missing, right? We actually have to do this if we want to see it. If we want to see the value, we have to do that. That's what the standard namespace character out does. Okay? And it should give us, as expected, the value 0. Alright, I'm going to leave it at that, guys, gals. I'm going to do quick yays. I am on... We're not really moving so fast, but there you go. Okay, we did a little simple program in our int main. Pretty basic, guys. Right? Easy peasy. It's not so bad, right? It's not so bad. We're going to continue. We'll do some more examples, and then we'll talk about case sensitivity, and then we'll talk about naming conventions, and that'll be kind of the next video. And yeah, stay tuned. It's great to have you guys and gals, brothers, sisters, Twitch and YouTube. Twitch, you guys on Twitch, man, you guys are all legends. The views you guys are doing here on Twitch, I don't think YouTube deserves my time. Sorry, YouTube guys, but it's like, what's up? What's up? The first video, you give me 150 views, and then after that, it's like, you don't want to learn? What's up? What's with YouTube? What's the difference? You guys on Twitch, you guys are awesome. Thank you for learning. Thank you for watching. Every single one of you legends. Well, I mean, every single one of you that are watching and learning. You mean you guys are all 120, and you know, you guys are awesome in my books. Whether you're on Twitch or YouTube, if you're watching, listening to me talk right now, you guys are legends. I'll appreciate you. As appreciates, yes. I'll see you in the next video. Take care, whoever you are, wherever you are. Have an awesome rest of your day, evening, and or night. Well, actually, it's an or, not an and. We'll talk about and/ors in the future. Stay tuned. Keep up the views, guys. You guys keep me going, all right? Keep it up. That is it. Johnny Whiskey Tango Coding appreciates you. Take care for now. And peace!
Changing, I can't stand it. My heart can't take this damage. In the way I feel, can't stand it. Baby, I don't understand it. You're changing, I can't stand it. My heart can't take this damage. In the way I feel, can't stand it. Baby, I don't understand it. Changing, I can't stand it. My heart can't take this damage. In the way I feel, can't stand it. Baby, I don't understand it. I don't understand it. I don't understand it. Girl, you're making it hard for me. Girl, you're making it hard for me. Girl, you're making it hard for me.
Incoming dishes! Doc!